Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problem 2 of the 2017 AP Calculus AB free response question. And the goal here is to not just solve the problem, but to go over some techniques, some strategies, formulas, and tips that can help you to be successful in solving problems like this in your upcoming AP exam. All right, let's go ahead and read the question. It reads question number 2. This is an amount rate problem. It reads, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t, which is given here over this interval from 0 to 12, where f of t is measured in pounds per hour and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t, highlighted here from the interval 3 to 12. G of t is measured in pounds per hour, just like f of t, and t is the number of hours after the store opened. Okay, so one thing you want to start off by noting is that we're given the rate functions here. Okay, the first function is the rate of removal, so let's call that removal rate. And then the second one is the rate of addition. Okay, so the second one we're going to call this the add rate. So you're dealing with an amount rate problem where the rates are what is given. So you need to know exactly the nature of what you're starting with so you can set up the problem correctly. Now what we're going to do first is take a look at some formulas that will guide our problem solving process, and these can be applied to most amount and rate problems on the AP exam. Okay, so we'll take a look at the formulas first, and then while we're solving the problems, we'll reintroduce the relevant formulas. So let's start with the total amount formula. Total amount, let's say you're given the rate functions. Total amount can be computed by the following expression. You need to know the amount added. Okay, the amount added minus the amount removed plus the original amount. Okay, the different AP exam questions have different formats. So this one has to do with the amount on display. That's what total amount means. It could mean the amount of water in a pipe that's draining and being filled up. It could represent the amount of glass clippings. It could be the amount of sand on a stack. So it could be anything. So you just adapt the formula to the particular situation that you're dealing with. Okay? In the context of this problem, total amount means the total amount of bananas on display. Since you're given the rate functions as your starting point, how do you compute the amount when you're given rates? This is how you do it. The amount added is simply the accumulation from A to B of the rate of addition function with respect to time, dt, minus the accumulation or the definite integral from A to B of the rate of removal function. Okay, and then you add on, this is very important, most students forget it. Don't forget to add on the original amount. How much did you start with before you started adding and removing stuff like bananas? Okay. Now this first two integral expressions basically represents the net amount. Okay, with the starting number of bananas, is a net amount a positive value which is added to the original amount, or is it a negative which results in subtraction? Okay. Another thing you want to keep in mind has to do with the rate of change of amount. Okay. Another word for rate of change is increasing or decreasing of the amount at a particular time, or the derivative of the total amount function. Okay. So let's just call this increasing or decreasing amount. That's simply determined by differentiating this expression we have up here. Okay, so we differentiate with respect to time the rate, the amount added So the integral from a to b of the amount added function, rate of addition, dt, minus the amount removed function, a to b, of r, rate of removal, dt, plus the original. Okay? So just by executing these steps, we're going to end up with a very elegant result. So minus original amount. So what happens when you differentiate this expression right here? If we apply the second fundamental theorem of calculus, we can easily evaluate what the derivative of these integrals are. The derivative of this integral is simply going to leave us with the rate of addition minus the rate of removal. Okay? Guess what the derivative of a constant value is? It's 0. Okay? The amount of bananas on display doesn't help you calculate if it's increasing or decreasing at a particular point in time. It's the difference of the rates that tell that to you. Okay? So just by looking at the difference of the rates at any point in time, you could tell if the amount of bananas are increasing or decreasing. Okay? So let's call this the net rate. The net rate. Now something that's cool about the net rate is that the sign can tell you the direction of the change. Okay? If the sign is positive, guess what? It means the amount of bananas are increasing. Okay? And if it's negative, that means the amount of bananas are decreasing. Just to illustrate, if the rate of addition is bigger than the rate of removal, then what do you think is going to happen? The amount of bananas will start to build, right? So the amount is increasing. But if the removal rate is bigger than the rate of addition, so is getting exhausted at a faster rate than bananas are being added, guess what? The pile of bananas on display will start to decrease. Okay, so just by looking at these rates, you can tell if it's increasing, if the amount of bananas on display is increasing or decreasing based on the sign. Okay? And the last thing you want to keep in mind is the rate of change of the rates. Okay? Is the removal rate increasing or decreasing? Is the addition rate increasing or decreasing? So we're just going to call that the increasing or decreasing of rate. Increasing or decreasing of rate. Okay, so we have two here. We're going to break it up for adding. To know if the add rate is increasing or decreasing, guess what we're going to do? We're simply going to differentiate the add rate. Okay, and then that can be expressed as r rate of addition prime with respect to time. Okay, so the derivative of the add rate function can tell you if the rate of addition is increasing or decreasing. Okay, and then if you differentiate the rate of removal, which can be written as the rate of removal function prime, this can tell you if the rate of removal is increasing or decreasing at any specific point in time. Okay, so let's call this is the add rate, and this is the removal rate here. Removal rate. Okay, now let's connect these formulas to the fun chart. If you don't know what the fun chart is, the fun chart is a very powerful tool that can help you draw connections between the behavior of a function and the sign of the derivative, or the behavior of the derivative and the sign of the second derivative. Okay, so let's go ahead and take a look at that real quick. So it's called a fun chart because you start with f, concave up, concave down. So that's fun. And then you have f prime. Let's do that again. We have f, we have f prime, increasing, decreasing, and then we have f double prime, positive, negative. Okay, so we have the first column that connects the concavity of f with the behavior of f prime and the sign of f double. And then the second column, all you do is you just take increasing, decreasing, positive, negative, and just apply to f and f prime. Okay, so increasing, decreasing in f just tells you that f prime is positive or negative. Okay, and then down here you don't have anything. Now let's go over what the fun chart tells you real quick. So this is just a black box right here. It doesn't tell you anything. What this tells us is that when f is increasing, f prime is positive. If f is decreasing, f prime is negative. If f is concave up, f prime is increasing, f double is positive. If f is concave down, f prime is decreasing, f double is negative. Okay, so that's basically what the fun chart is. Now, in this particular problem, we are just going to connect it to the whole concept of amount and rate. Okay, so we have A, amount, we have the rates, and the rate of the rates. All right. Now, in this particular problem, the amount, if you look at the question, the amount, the rate functions are provided, and they're provided as just functions. So we have to make a slight modification to the fun chart. What we have here is a scenario where this is just a function. So to get rid of the derivative, guess what we're going to do? We're going to have to integrate everything, okay? So this is not just a fun chart. This is going to be a super fun chart. So you have the integral of f, and then when you integrate f prime, guess what? The derivative is gone. And then when you integrate the second derivative, you get the first derivative. So it's just a shift of the entire fun chart up the integration continuum. Okay? All right. So this whole concept, just to highlight just a point, is that when you're going down, you're differentiating, and then when you're going up, you're integrating. Okay? All right. So we have the amount is equivalent to the integral of f. As you can see in the formulas that we showed here, when we're looking for the amount, we're integrating rates. The rate function is equivalent to f and g, and then rate of rate is just the first derivative. I wonder why I have two. So it's just the first derivative. Okay, so there you go. Another thing that you can do is when you have your fun chart created is to input your units. Okay, so you might have noticed in the problem the amount is in pounds. Okay, the rates, the time measure here is in hours. So the rate of change of the amount on display is in pounds per hour. And then the rate of the rate is the rate of addition or removal, increasing or decreasing. That's going to be pounds per hour square. Okay, so another way to think about this is distance or position, velocity, and acceleration. Okay, position, velocity, and acceleration. This is just the length, like meters, and velocity is meters per hour, and acceleration is meters per hour squared. It's the same idea here. All right, so we have everything set up. We can go ahead and start with the problem. Okay, question 2a. It reads, how many pounds of bananas are removed from the display table during the first 2 hours the store is opened? So in this problem, we need to find the amounts. Okay, how many pounds? The amount removed. Amount removed on the interval 0 to 2. Okay, so what's the formula to help us with this? Formula is as follows. The amount removed, if you look back to your notes, the amount removed is basically the accumulation of the rate of removal over the time interval. So integral from, I think we put, integral from a to b of the rate of removal with respect to time dt. Okay? Alright, so we just need to find the limits of integration and the removal rate. In this problem, the removal rate is the f of t function. Okay? And the lower bound, the starting time, is 0, and the upper bound, the stop time, is 2. You have to be extremely careful with your limits of integration. You have to read the problem carefully. So let's go back to the problem. If you notice here, the rate of removal, f of t, goes from 0 to 12, but the rate of addition goes from 3 to 12. So never assume that the same time interval applies to both functions. You have to be really careful to make sure you're starting at the right time and you're stopping at the right time also. Okay? Alright, so we have everything set up. So the amount removed is going to be the integral from 0 to 2 of our f of t function dt. Okay? Alright, so what I'm going to do to save time, I'm just going to store the function in my calculator and integrate. Okay, because we're going to be using f of t multiple times. So let's go ahead and do that real quick. Let me clear my home screen here. So let's go ahead and enter the f of t function. Where are you? Yeah. Okay, so you know what? I'll just enter both of them while we're at it. So 10 plus 0.8, 0.8 t sine t to the third divided by 3. No, divided by 100. Close that. Now it's going to look weird because I have my mode in exact format. Let me switch that to decimal format. So I'm going to press mode, go to F3, no F2, a second page, and I'm going to change from exact to approximate. Okay, because this is a calculator section and decimal answers are fine. Okay, so whenever you store a function, I haven't stored it yet. I'm just trying to make sure that what I entered is correct. 0.01 is 100 times t. Okay, that's good. Now I'm going to store it in f of t. Okay, so let's store it in alpha f of t. Enter. Okay, it's done. Well, just to make sure, let me just call up f of t again just to be sure. So f parenthesis t, f of t, enter. So we have 0.10 is over here, that's fine. 0.8 sine t to the third over 100 is the same thing as 0.01 t to the 100. Okay, we have that. Now, let's go ahead and store the second one. So the second one for g of t, 3 plus 2.4 times the natural logarithm of t raised to the second power plus 2t. Okay, and then let's store that in g of t. Enter. Okay, let's call back g of t again just to make sure that we entered it correctly. So you want to inspect it completely the first time so you don't have to go back to it again. Just make sure it's right the first time, okay? So you have 3 right there, 2.4 natural logarithm of t squared plus 2t. It factored it. The calculator does this. Alters the entry, but it's still the same thing. T squared plus 2t is the same as that. Okay, so we're ready to go. Let's go ahead and evaluate this integral right here. Since it's already stored, all we just have to do is let's escape. I want to evaluate the integral of f of t. So since I already have f of t sitting somewhere here, I'll just call it back in here. Variable of integration is t, and we're going from 0 to 2. And then press enter. Okay, so you notice another benefit of storing the function. Instead of typing in the long expression for f of t, which increases your odds of making mistakes, that's not an issue here. We just enter f of t and the entire expression is inserted here, and then it just gives you a nice answer, reducing the odds of making calculator entry errors. Okay, so our answer is going to be 20.05112. So the amount removed is approximately 20.0511. Wait a minute, I already forgot the answer. 512. Oh, I changed that. 0512. Alright, so try and carry your answer to at least 4 decimal places to be on the safe side, because on the AP exam you have to be accurate on up to 3 decimal places, or else you're going to lose points. Okay? Now this problem, you earn 2 points for this problem. You earn 1 point for setting up the integral correctly, and you earn another point for getting the final answer. It's good practice to include the units, so let me just put the units there. This is an amount, and the amount is in pounds. Even though, let me make sure, the question didn't specify to indicate the units, but it's a good practice to do that so you don't forget. So you get a total of 2 points for question 2, part A. Alright, let's take a look at the B part. It says, find f prime of 7 first, and then using correct units explain the meaning of f prime of 7 in the context of this problem. Okay, so we know what f of t is, right? It's clearly stated there. F of t is the removal rate at any time t. Okay? Now, if we want to find f prime of 7, there are 2 steps to this. Let's address this on the side right here. To find f prime of 7, you have to execute 2 steps. The first step involves finding the derivative. You need to find f prime of t. Okay, and then after you're done finding f prime of t, you then have to evaluate the derivative at the specified time value, which is 7. Okay? Alright, so what is f prime of t? What on earth does that mean? If we can determine what this means, then we can apply it to a specific time. Okay? If f of t is the removal rate, f prime of t is the rate of change of the removal rate. So it's either the increment or decrement of the removal rate. So increasing or decreasing of the removal rate at any time t. At t, okay? But when you're looking at f prime of 7, what this is asking is it increasing or decreasing at what rate, at what particular value? We're talking about the removal rate. Okay, so the removal rate is it increasing or decreasing at t equals 7, and the value tells you the magnitude of the increment or the decrement. Okay, all right, so let's go ahead and solve the problem. Let's start with part 1. Part 1, we're going to find, well, you know what? Since we're using a calculator, we can just consolidate both steps into one. Okay? So what we're just going to do is just evaluate f prime of 7 using our calculators. We already have it stored, so this should be a piece of cake. Alright, so let's find f prime of 7 first. That's the first part of the question. So all you just do is you just evaluate the derivative of f. Where are you? I'm going to just copy you. Yeah, there you are. Enter. So the derivative of the rate of removal function, the variable of differentiation is t. You're differentiating with respect to time. Now what this returns is the derivative. I want to evaluate the derivative at t equals 7. So just put t equals 7 there. And then just press enter, and you get negative 8.11954. Okay? So f prime of 7 is negative 8.11954, I think. Let me check again. 8.11954. Okay, good. So we have the answer, which is good. That gives us 1 point. But we have to explain using units. Oh, now we have to use units. Using correct units, explain the meaning of f prime of 7. So let's go back to our super fun chart for a second. We are looking at f prime, okay? So f prime, we are right here. Bam. So we're looking at pounds per hour squared, okay? So if f prime of if f prime is positive, that means the rate is increasing, right? If f prime is negative, that means the rate is decreasing, okay? Because this is the rate of change of the rate. So since we have a negative answer, what we're just gonna know is that the rate of removal is doing what? Is decreasing, because it's minus, at the rate of negative 8.1195, the units, pounds per hour square. Okay? And yeah, and that's because, well, that includes the negativity. So let's go ahead and write down what the answer means, or explanation of the meaning. So meaning f prime of 7 equals, oh, it's not equal, it's approximate. It's an approximation. F prime of 7 is approximately negative 8.11954. Um, means that, oh, pounds per hour square, means that the rate at which, or rate at which bananas, just put in the context of this problem, the rate at which bananas are removed from where? From display, right? The rate at which bananas are removed from display at a specific time, what's the time? At t equals 7, is decreasing at negative, or is decreasing, well, if we say decreasing, we don't have to put the sign anymore. It's decreasing at 8.11954, and we have to include the units, pounds per hour square, or pounds per hour per hour. It means exactly the same thing. Okay, so in this particular problem, if you input this expression into your calculator and you generated this response, negative 8.11954, you will earn 1 point. So 1 point for the accurate value, and then you earn another point for your explanation. Okay, so the problem says explain. Don't just write down your answer and run off to the next problem. If you want to earn full credit, you have to include your explanation. Okay, so 2 points for question 2b. All right, let's take a look at 2C. It says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? Give a reason. So, oh, we have to give a reason here for our answer. All right, so let's go ahead and write down the formula for this problem. Formula is for increasing or decreasing. This is rate of change. Increasing or decreasing what? Number of pounds of banana. Increasing or decreasing amount. Okay, we talked about this earlier. Let's go back and take a look at it. So, increasing or decreasing amount, we said if you differentiate this integral expression right here plus the original, or if you just look at the net rate, that will tell you if the amount on display is increasing or decreasing. Okay, so we don't have to write this whole thing down. We can just look at the net rate because that's what's changing. Okay, all right, so let's write that down. So increasing or decreasing amount is simply the net rate. Okay, the rate at which banana is being added minus the rate at which banana is being removed. Okay, so this is supposed to be A, rate of addition minus rate of removal. Okay, we're looking for the increasing or decreasing amount or the net rate at t equals 5. Okay, so let's go ahead and write that down. So I'm just going to call it net rate or n of t. Net rate is going to be, we're going to call that n of 5. So that's going to be the rate of addition of bananas to the display is g. Okay, so let me specify those before I start my calculations. So we have what do we have? Rate of addition. Rate of addition is uh, g of t. Okay, and then rate of removal is what? F of t. Okay, good. And then we're gonna define our net rate or increasing or decreasing amount. Net rate is simply the difference. Add-in rate minus removal rate. Okay. At t equals 5, n of 5 is just going to be g evaluated at 5 minus f evaluated at 5. Okay. So the instantaneous rate of change of the addition of bananas at 5 minus the instantaneous rate of change of removal at 5 will tell us. Okay. Um, so let's go ahead and just simply input that into our calculators, and we should be good to go. Okay. So I already have my f and g. You know what? Let's see. Oh, there goes f right there. I need to do g. So where are you, g? Okay, there goes g. So g of t minus f of t. So this just returns the difference in the net rate function. I don't need the net rate function. I need the net rate function evaluated at 5. So I'm just going to compute g of 5 minus f of 5. Okay, enter. We get negative 2.2631. All right, let's write that down. So negative 2.2631. Negative 2.2631. Okay, so what does this mean? The question asked, is the number of pounds of banana on display increasing or decreasing? This is the rate at which it's decreasing. But the question is just, is it increasing or decreasing? The answer is, it is decreasing. Okay, so we're gonna write that down. The number of pounds of banana is decreasing at t equals 5. Is that good enough? Well, the answer is no. This is just for one point. We're asked to give a reason. And what's the reason? It's decreasing because the net rate is negative. Okay? So, because the net rate, or we want to specify exactly what we computed here, g of 5 minus f of 5 is less than 0. Okay, so if it's less than 0, that indicates that it is decreasing, the amount is decreasing. Okay, now let's connect that to our Superfund chart real quick. Okay, so we're talking about amounts and rates. You can see here that if the net rate is negative, then the amount is decreasing. Okay, so that's just what we did. We computed the net rate, and then we used that to inform our decision as to if whether the amount is increasing or decreasing at that specified time that we evaluated the net rate at. All right, the last one. It says how many pounds of banana are on display at time t equals 8? So from 0 to 8, how many pounds are on display? Okay, so what this is asking for is basically we need to find the total amount. Total amount going from 0 to 8. Okay, so let's go ahead and write down the formula for that will guide our problem solving process. So the formula is as follows. So the total amount on display, that was the first formula we looked at, right? So let's just write it again, is the integral, the accumulation of the um, rate of addition, so a to b, rate of addition, respect to time, and then minus the um, accumulation of the rate of removal. So instead of using a to b, I'm going to just use so a to b, let's go from c to b because we're starting from a different time frame. So c to b of the rate of removal with respect to time, and do not forget your original amount. Alright, so let's go ahead and apply this to the problem. So total amounts on display, total number on display is going to be the integral of rate of addition is the g of t function. Okay, now if you notice, if you look at the problem, the g of t function is only active from 3 to 8. Okay, so you got to be careful with that. And then we'll subtract the rate of removal. So we'll subtract the rate of removal, which is the f of t function, which started right from the open. So from 0 to 8 of f of t dt. And then we'll add the original amount. So how much bananas were there originally? There were 50. So plus 50. Okay, so just enter this expression in our calculators and it will give us the approximate amount of bananas that were on display, the approximate pounds of bananas that were on display at t equals 8. Okay, alright, so we have everything stored in our calculators already, so it shouldn't be too hard for us to compute this. So what we're going to do is we're going to calculate the integral of g of t. Let me just type that in, g of t, integrating, variable of integration is t, lower bound is 3, upper bound is 8, plus, well, we're going to have another integral. We're integrating f of t. The lower bound, variable of integration is t, lower bound is 0, all the way to 8. And then we'll add our constant, which is 50. Okay, wait a minute. We have to subtract the rate of removal, so minus. Okay, press enter. It's calculating. 23.3474. Okay, so answer is 23.3474. Alright, so what does this mean? It just means that 23.34, let me make sure my 34, okay, that's right. 3474 pounds of banana are on display at time t equals 8. Okay, so that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calc exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or any questions on the AP exam in general, just post them in the comment section below. Okay? Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day. Goodbye.